The next experiment is how to characterize a strain gauge sensor. The aim, theory, procedure, review questions, references are already there with the experiment. You are advised to read carefully the theory first, then procedure, and then perform the experiment. Go to simulator. Now you can click here for simulator. Now this experiment, you will have a lot of configurable parameters. This experiment is of two levels. In level 1, you are selecting what will be the material of construction of strain gauge. For example, I have selected copper as a material. Input voltage for excitation 5 volt DC. The resistance which I have selected for strain gauge is suppose 120 ohm, and the configuration, there are 4 types of configurations you can have. One is called as quarter bridge, half bridge in adjacent arms, half bridge in opposite arms, and full bridge. Now in this case, if I select full bridge, you will find that these strain gauges, all the strain gauges and all the arms of this bridge are active. Instead of that, if I select half bridge opposite, you will find strain gauges are kept in opposite arm and the fixed resistors are kept in the opposite arms. Instead of that, if you go for half bridge in adjacent arms, you will find the configuration would be like this. And then if you go for quarter bridge, only one strain gauge would be available and would be connected in the bridge. Now, each configuration has got distinct advantages and limitations. You are advised to read the theory carefully and as per your application, select whether the configuration should be quarter bridge or full bridge. Then select the gauge factor. Gauge factor is varying from 0.9 to 8.5. Suppose I have selected 0.9 as gauge factor and then configure the entire system. Once you have configured it, you will say yes. Indicates that the material of construction is copper, input voltage is 5 volt, resistance is 120, gauge factor is 0.9, and quarter bridge you have selected. Now you will have to keep on adding weights on this cantilever beam, and the strain gauge is installed at this point where the maximum sensitivity would be there. So you will select how much weight you want to add. For example, if you have added 0.5 kg, the RG value or the gauge value, resistance of the gauge would be 120.0136. Then calculate output voltage in millivolt by using this formula. So this formula is dr equal to gauge factor into dl by l into r, where you have already given all the details about the applied weight, distance from load point to HG center, width of cantilever, thickness of cantilever. All this are given. Please read it carefully. Use this table for Young's modulus, linear expansion coefficient of strain gauge. After solving this, enter value of output in millivolt. You will have to do this exercise 3 times. Now change the position, change the weight. Suppose I have added 4 kgs and I will calculate what will be the output of strain gauge in millivolt if you have added here a weight of 4 kg. Submit it. It's correct. Then change this to suppose 8 kgs. And then submit. After 3 readings, the plot will be available. Now this is the characterization curve of weight versus output in millivolt if you have connected strain gauge in a specific configuration as mentioned before. Now you will find that level 2 is now on. Now level 2, if you click on to level 2, this is used to demonstrate the effect of position of weight on the output of the strain gauge bridge. Now select here the position in centimeter. For example, if I select position in 16 centimeter or if I select 10 centimeter, this is 16 centimeter and this is 10 centimeter. The last weight we added was 8 kg, so this weight would remain as 8 kg. The output will become 1.41. You go on changing these values, you will find the output weight will go on changing. So if you add here 9, output voltage in millivolt will become 1.27. You can plot a graph. Now the graph will indicate that according to position how the output of the strain gauge is changing without changing the weight. And because of this, now you are eligible to go for level 3. Here load is connected maximum away from strain gauge, that is 16 centimeter, and the output is 2.26 millivolt. In all other cases you will find that the output was reducing, naturally the bending moment is less. Now go to level 3. Now level 3 is identifying what will be the effect of temperature on the performance of strain gauge. The RG value or the resistance of the gauge, which we have considered as 120.2169, is at 20 degrees Celsius. Now if I expose this to 30 degrees Celsius, what will happen? The new value of RG will become 115.28. Now if you will go on changing this temperature, the new value will go on decreasing. So in other words, if the temperature is 10 degrees, 120 becomes 24.97. So in other words, as you are increasing the temperature, resistance will go on decreasing. So here for 40 you get some value, but if you expose it to 10 degrees you get higher value. Now this is how 3 stages of experiment can be proved. One is the bridge configuration, it's called as level 1. Level 2 is position of the weight, and level 3 means what will be the effect of temperature on the performance of the strain gauge. Now this calculation will clearly reveal that there would be effect of change in temperature on the performance of the strain gauge. Hence, if you are measuring strain, temperature compensation is mandatory.